Welcome to part 2 of lesson 6. We are going to talk about the discriminant and the nature of the roots. So we just did an entire lesson on the quadratic formula. Within the quadratic formula, the expression b squared minus 4ac is called the discriminant. Because the discriminant is under the radical symbol, the value of the discriminant can be used to determine the number of solutions of a quadratic equation and the number of x-intercepts of the graph of the related function. Some other synonyms for x-intercepts are the roots, the solutions, and the zeros. The discriminant gives us a lot of information. The value of the discriminant plays a role in the number of solutions for a given quadratic equation. So if the value of the discriminant is greater than 0, or another way to say that is a positive number, then there are 2 solutions. And remember, on the graph, those 2 solutions means there are 2 different x-intercepts. When the value of the discriminant is equal to 0, that means there is 1 solution. In this case, that 1 solution will be 1 x-intercept, which means that the vertex is typically the x-intercept. Then lastly, when the discriminant is less than 0, another way to say that is a negative number, then there is no solution. And like we talked about, that means that this parabola will be floating in the coordinate plane and will never intersect the x-axis. Let's roll through a couple of examples here. We are going to use the discriminant to determine the number of solutions. You will either say no solution, 1 solution, or 2 solutions. Like we did with the quadratic formula, let's identify what A is, what B is, and what C is for each of these examples. And I identified what A, B, and C are for all 3 examples below. Let's find the value of the discriminant in example 1. So using b squared minus 4ac, I'm going to substitute 6 into b squared minus 4 times 2 times 5. Now we know 6 squared is 36, 4 times 2 is 8, and 8 times 5 is 40, and we know that 36 minus 40 gives us a negative 4. Now, since we have a negative number here, we will have no solutions. Since that discriminant is negative, it will never intersect the x-axis, so we will have no solutions. Let's take a look at this middle example here. I have b that is 0 minus 4 times 1 times 7. Obviously 0 squared is 0. And 4 times, oops, it should be negative 7. That is a typo on my end here. Negative 4 times 1 times negative 7 gives me a positive 28, and obviously anything plus 0 is that given number. So in this case, since this is a positive number, that means we will have 2 solutions or 2 x-intercepts. Now let's take a look at the third example here. I apologize. Let's do negative 12 squared minus 4 times 9. Negative 12 squared is 144. Negative 4 times 4 is negative 16 times 9, again, is a negative 144. 144 minus 144 gives us a discriminant value of 0. Means we will have 1 solution. Now let's take a look at the last 4 examples at the bottom here. We're going to get a little bit more descriptive with how we state the types of solutions. So the different types of solutions, we are actually going to state the nature of the roots. Depending on the value of our discriminant will depend on the different type of nature we define that discriminant to have. When there is one double root, that means the discriminant is equal to 0. When there are two rational roots, it has to be a perfect square and a positive number. When we have two irrational roots, it is a non-perfect square but it is still a positive number. And lastly, when we have two imaginary roots, that means we are getting a negative number as our discriminant. So not only does it have no solution, those solutions are two imaginary roots. So what I would like you to do is please try these 4 examples on your own. So hit pause and come back to check out the answers. Let's take a look at example A. Notice that the quadratic function is in standard form, so we can quickly find the discriminant. The discriminant here becomes 144. Since it is a perfect square and a positive number, we would describe the nature of the roots as 2 rational roots. In example B, first and foremost, you need to put that quadratic equation into standard form and then find the discriminant. Here, the value of the discriminant is 24. Since it is still a positive number, but it is not a perfect square, we would classify the nature of the roots as 2 irrational roots. Looking at C and D, when you find the value of the discriminant in C, you'll notice that the discriminant is equal to 0, so we would classify the nature of the root as 1 double root. And lastly, in D, the discriminant winds up being a -3, so that means that not only is there no solution, but those solutions are 2 imaginary roots. Now that we have wrapped up the unit, please complete the practice and the exit ticket on my page, and then we'll get started on our Angry Birds project. Bye for now!